This is the next video in our Covalent Notes Introduction video set. So you need to have this sheet in front of you. You also need to have available your chemical bond unit notes, the soft yellow sheet of paper, and you need to have the bright yellow sheet of paper with the electronegativity periodic table and VSEPR shapes on it, so with all the big molecule shapes on the back of it. So when we're talking about covalent bonding, there's some things that we're going to do here in terms of identifying and being able to draw Lewis structures, and I will go through the Lewis structure section on the notes in just a minute, but I'm going to walk you through here on this set of video notes all of the information that we need to write down in order to know as much about our molecules as possible. So the first thing that we want to do is we want to figure out our number of valence electrons, and so in this case right here, I know that hydrogen has 1 valence electron, and I know that chlorine has 7 valence electrons, so my total valence electrons are 8. Notice that also hydrogen is content because it can only have 2 valence electrons in its outer shell because it only has 1 shell, and that chlorine is also content because it has 8 electrons around its atom. You don't need to put the circles in there. Those circles are just to show you that both atoms are happy, so they're sharing their electrons and both are happy. The next thing that we're going to do is draw our Lewis dot. So in this case, anytime you have 2 atoms, you're just going to put those 2 atoms next to each other. And then you're going to take the 2 electrons and share them with hydrogen so that hydrogen is happy. And you're going to take the next 6 electrons and put them around chlorine. I'm going to give you much more practice and much more directions on doing Lewis dot structures, so if that was a little bit vague for you, that's okay. I will get back to it and you will see me complete Lewis structures many times in the next few videos, so don't stress if you're not quite understanding exactly how we put those electrons around the chlorine and around the hydrogen. The next thing that we're going to do is we're going to figure out the shape. So now we're going to reference the bright yellow sheet of paper, so please make sure that you have that in front of you, and we're going to write a few things down on that sheet of paper. So one of the things that we need to identify, and these labels are actually at the bottom of your yellow sheet of paper, but it's not showing up on the video right now, so I'm going to rewrite them. I know that when I'm talking about my variables and I'm trying to identify shape, A is the central atom, B are the atoms bonded to the central atom, and E are the lone pairs on the central atom. When we are trying to figure out shape, what we need to do is we need to identify how many electron groups and how many atoms and sets of groups around a central atom that we have. So if we have 2 groups right here, that's generally 2 groups of atoms, or we see that the molecule is going to be only 2 atoms or 3 atoms, we know that this is our shape. So here are our options for that. We could either have something with 3 total atoms, something with 2 total atoms, or 2 atoms that are the same. So for example, if I had BeF2, I can look and see Be is my central atom, and then my atoms bonded to the central atom are B, and so my type of molecule would be considered an AB2, but I see that my shape is linear because I have 2 groups bonded to the central atom, or 2 groups total. The next thing that we have is AB, and so for example we could have HCl, and so I would just have an AB like that, and I can see that it's telling me that my shape is linear. I can also have an A2, so this counts for all of our diatomic molecules. So here's my A and A, it's 2 of the same atoms, and so I would consider that A2. Again, there's only 2 things present here, and here there's only 2 things bonded to the central atom, and so that's why I consider it the 2 electron group. The 3 electron group are 3 things bonded to the central atom. These atoms do not necessarily need to be the same, it is simply what is bonded to the central atom. So in this case, I have 3 atoms bonded to the central atom, and I have what are called no lone pairs on the central atom. All of the lone pairs here on this central atom, all of the electron pairs are shared. Nothing is left by itself. So it would be AB3, and I would say that my shape would be trigonal planar, and we will be able to build all of these when we do our models lab, and you'll be able to see this shape as planar rather than bent, for example. So a way to label that, I've got my central atom here, and then I've got my atoms around the central atom would be AB3, and that will help me identify my shape. The next one, here we've got our central atom, for example, so I know I still have 3 things, 1, 2, 3 around my central atom, so that's why I'm in the 3 electron group. But in this case, I see that I have a lone pair of electrons. So that means that nitrogen, in this case, has 2 electrons, so it needs them there in order to be happy, and this is what we call lone pairs of electrons. So from the previous video set, you should remember that anytime we have a lone pair of electrons, we always have a polar molecule, and it's because it creates this bent shape, so it's not going to look the same on all the sides. If I were putting my variables down, I see that this has A, B, 2, and E, and that E, again, is my lone pair. Now let's move on to 4 things around the central atom. So first off, we have 4 things bonded to the central atom and no lone pairs. So here's an example. It could be AB4. AB4. There's our example. And real quick, there's where, hopefully you saw it before, but there's where my variables are, that I have them labeled. AB4 could also be, like I was saying before, those atoms bonded to the central atom do not necessarily need to be the same. So that still counts as an AB4 because it's 4 things bonded to the central atom. So now if we look, if we've got 3 things bonded to the central atom and 1 lone pair, it would look like this. So we would have an AB3E atom, and again, it's got a lone pair, so in your heads you should be thinking, I have a polar molecule. And the last example is where I've got 2 atoms bonded and 2 lone pairs on the central atom. And we will come back and talk about this a lot, but it is so important that you know that water has lone pairs on the central atom and that water is a polar molecule. Pretty much why we've got the water properties that we do is because water is a polar molecule. So AB2E2 would be the type of molecule that we would line up and answer for what a water molecule is in terms of its shape. So now let's go back to our sheet and let's look at what we've got here. So I've got 2 atoms and they are different. So I would identify that as an A and a B. And I know that because there's only 2 atoms, I can look at my atom sheet and I can see that 2 atoms is going to be linear. And I will be able to say AB and that my atom is linear. The next thing I'm going to do is figure out the bond type. So the type of bond, we're going to use the electronegativity periodic table. So that's the front side of the Vesper shape that I was telling you about just before with all of the shapes on it. So it looks like this. So now what we're going to do is find hydrogen on our periodic table, so that's 2.1, and then chlorine on our periodic table, and that's 3.0. And we are going to subtract those, and that will give us the bond type. So if we go 2.1 minus 3.5, we would get 1.4. And we know from our notes that anything from 0.3 to 1.9 is a polar covalent bond. So that polar covalent bond tells us that those electrons are shared unequally. So then the last thing that we've got to do is figure out the arrows. And it's kind of drawn in here already for you, but let's go back to the notes and remind ourselves that anytime I have a polar covalent bond, I want to draw the arrow with the arrowhead pointing towards the more electronegative atom because it's going to be showing that the electrons are hanging out more around that electronegative atom. So for example here, we would show that arrow right like that. Please do that in a different color so that we can see that you actually are working with remembering what that electronegativity difference is. And then the last thing that we're going to identify is the type of molecule. So if it's a polar or nonpolar molecule, remember, if it's a polar molecule, it looks different, and if it's a nonpolar molecule, it looks the same. Because these two atoms are different, they look different, so I would consider this a polar molecule. So again, it does not look the same, so it's considered a polar molecule. So now let's go through all of these 5 things with our hydrogen as an example. So the first thing we're going to do is find the valence electrons. So hydrogen has 1 plus 1, and it's going to equal 2 valence electrons. The next thing we're going to do is the Lewis dot. Anytime we only have 2 molecules, we're just going to set them, or 2 atoms, we're just going to set them side by side. And then in this case, because there's only 2 total atoms, we're just going to start by sharing them in the middle. And that makes sense because hydrogen can only have 2 total atoms. A rule about making Lewis structures is that we're always going to, when electron pairs are shared, we are going to replace the dots with a dash. We have 2 electrons for both of the hydrogens, so we know that both of those are happy. And we're going to replace that dot with a dash. So that's one of the rules of Lewis structures, and again, I'll continue to review those with you. The next thing we're going to do is look at the shape. So we're going to label. These are the same thing. So I would label A, and I see that I have 2 things, so A, and I look on my VSEPR sheet, periodic table, backside of the electronegativity periodic table, and I look and see that A2 tells me that it's a linear molecule. I look on the front side of my bright yellow sheet on the electronegativity periodic table and figure out my electronegativity difference. I know that hydrogen is 2.1 minus 2.1, so that would be 0, which means it's a nonpolar covalent bond, which means electrons are shared equally. And then lastly, I would look at the type of molecule. Oh, and then we got to do the arrows. Don't forget the arrows. So here I'm showing that the electrons are shared equally, so I've got the electron arrows going both directions to show that the electrons are shared equally within the atom. And now lastly, we'll look at the molecule polarity. So if we just look at this right here, it looks the same on all the sides, and so we would consider that a nonpolar molecule. Alright, the next set of video lesson is going to be explaining oxygen and water and the setup.